All right, we are going to do example 1, and then we're not going to do example 3, so you can take out of your notes. This is probably the hardest of our solving that we're going to have to do. Now, on your test, right, you guys are going to get your identity sheets, the same ones that you got for your quiz question.
What is that?
7-5 notes. You'll get your identities. You'll get the unit circle. This is the same kind of a problem we had yesterday, right? Do you see how it's one trig function is squared, the other one's to the first power? How is this different, though?
Different signs.
Because the trig functions are different, right? So if we're going to try and factor this, and we would try and factor because we see that one is squared and one is not. So let's just move everything to the other side. So if I move this over, this becomes -2 cosine squared theta plus sine theta plus 1 equals 0. Now, on your test, you'll have one of these. And again, you're going to get your identities because we can do stuff with our Pythagorean identities to change from one trig function to another. Question?
Would it be wrong if you just did 1 plus sine theta minus 2?
No, that's fine. The only reason I wrote it like that is because you want, at the end, like when we go to factor, you're going to want everything to be in descending order. But it's fine if you left it like that for right now. When you have two trig functions, one squared, one that's not, and you're trying to factor something like that, you always want to try to convert to the middle trig function, to the one that is to the first power. So this is where we would look at our trig identities. All right, now again, you're going to get those on the test. So I'm going to think about this one, the one that we talk about all the time. Sine squared theta plus cosine squared theta. What does that equal? 1. Good. Can I change this blue formula that I wrote at the top to be written in terms of cosine, meaning where it says cosine equals something? Can I do that? What can I do so this formula said cosine squared equals? I could subtract the sine squared, right? I could move that over here. So do you guys agree that I could replace this cosine squared theta with 1 minus sine squared? And the reason we did that is because now, do I have the same trig functions? Yes, one of them's just squared, one of them's not. So the first step, one of your questions on your test will be like this, where you have two different trig functions. One of them's squared, one of them's not. You're going to want to convert to the middle one, the one that's to the first power. And you'll use your Pythagorean identities to do that. And now we just go back to our basic algebra thinking. What do I do with this -2 here out in front? We distribute it. So I have -2. A negative times a negative is a positive 2 sine squared theta plus sine theta plus 1 equals 0. Everybody with me? Well, now, ladies and gents, do you see anything that we can combine? Yeah, the -2 and the positive 1, right? So then this would become 2 sine squared theta plus sine theta minus 1 equals 0. Now, somebody last period asked me, I didn't write it in that order, which, okay, I understand that. But you guys, we always want to write our equations in standard form, meaning your exponents are descending, they're going down. So do you see how you have the first term is squared, the second term is the first power, and then there's nothing on the third one. So it's in descending order. But this is just a factoring problem. Instead of x's in the front of both of my parentheses, what am I going to put? Sine and sine, good. Sine theta. And then I'm going to multiply. What is 2 times -1? -2, right? So what are the factors of -2? That'll multiply to give me a -2. But add to give me a positive 1 right there. Plus 2 minus 1. Perfect. My a term is not 1, so what do I do with it? Divide both of these by 2. So I end up here, I'll come down here, with sine theta plus 1 times 2 sine theta minus 1. Both equal 0, yeah? So now I just have two very basic trig equations to solve. The left-hand side, I have sine theta plus 1 equals 0. The right-hand side, I have 2 sine theta minus 1 equals 0. So on that left-hand side, how do I get sine theta by itself? Subtract 1. So I have sine theta equals -1. On the right-hand side, what do? I'm going to add 1 and divide by 2. Good. So I have the sine of theta equals positive 1/2. Very good. Now, that's not what my answer is. I don't want the sine of theta. I want to know actually what that value is. So we look at the unit circle, and that's the y value. Good. So we're going to have 2 different values that we're looking at. That doesn't even look like it says value. Y value. Where is the y value on the unit circle? -1. 3 pi over 2, good. 3 pi over 2. And then where are the y values? Positive 1/2. Pi over 6 and? Perfect, 5 pi over 6. Now notice, guys, on both of these, and Sarah pointed this out yesterday, I always use the letter x, but it really says theta equals. Everybody with me? That's the hardest kind of problem that you're going to have to do. It's where you have a factoring, and it's going to have one trig function that's squared and one that's not, and then you have to convert it. But you'll have your identities. It's not going to be anything too crazy, I promise. Promise, promise. Yeah.
You have to write.
All right, here's the questions that are a tad bit different. 2 of these. These are very, very, very simple, I promise you. The only thing that's different is one thing at the end, one little step. How is this problem different from any of the ones that we've done so far? Do you see anything different?
Yes.
What?
There's like a sine 3.
There's a 3 there, right? Every time you guys have solved, I've said, ooh, we need to isolate our trig function. And usually when you highlighted it, said sine theta, cosine theta. It didn't have a number in between it. So this is a multiple of an angle problem. This is where you would say, oh, I have one extra step at the end. Nothing crazy though. Let's just solve. Let's isolate our trig function like we have been. So what would we do? I'm going to add 1 to both sides. Good. So I have 2 times the sine of 3 theta equals 1. Then what? Divide by 2. Perfect. Same exact thing. So now this says sine of 3 theta equals 1/2. We do the exact same thing. What is sine? Y value, right? So where on your unit circle are the y values? 1/2. Pi over 6. We just had this. Pi over 6. And 5 pi over 6. Now, we have done absolutely nothing different in solving than we did the first day we did this. The only thing that's different now is this theta equals pi over 6? It's what? It's 3 theta equals this. We don't want 3 theta, guys. We want what? Just theta. So how do you get rid of the 3? You divide. That's it. You can divide by, do you guys agree it's 3 over 1? Okay, divide by 3 over 1. So we keep, change, 3 over 1 becomes 1/3. So what's my answer? Perfect, pi over 18. Same thing on the right hand side. Divide both sides by 3. It's 3 over 1. So 5 pi over 6 times 1 over 3, and I get 5 pi over 18. Whenever there is a a number stuck with your angle, if it's being multiplied by the angle, then once you find the angle in the unit circle, you're going to divide by that number. In our next example, it's just the opposite. It's already being divided, so at the end, you're going to do what? Multiply. Yep. All right, I talked to you guys yesterday about tangents and why it was so important to know where tangents were a certain value. Look, if I highlight, I'm going to isolate my trig function. What's the first thing I'm going to do to solve this? I'm going to add 1. Good. So I have the square root of 3 times the tangent of theta over 2 equals 1. I still want to get my trig function by itself. I have the tangent, theta divided by 2, times the square root of 3. So what do I do to both sides? I'm going to divide by the square root of 3. So I divide by the square root of 3. I can't leave it like that, can I? How do I rationalize? Perfect. Multiply top and bottom. So you have tangent of theta over 2 equals the square root of 3 over 3. Now, I told you guys yesterday something that was really probably smart for you to memorize is where the tangents were what value. Right? My tangent here, when I put 0 over 1, my tangent here is 0. My tangent up here, when I put 1 over 0, my tangent is undefined, right? Right here, my tangent is what? When I have square root of 2 divided by square root of 2? 1, good. Now it's the other ones. There's two leftovers. There's one tangent, that'll be the square root of 3. And there's one that will give you the square root of 3 over 3. Does anybody remember?
Is it the pi over 3?
Pi over 3. When my x value is 1/2, my tangent will be just the square root of 3. When my x value is the square root of 3 over 2, my tangent is the square root of 3 over 3. Now again, if you don't memorize that, guys, you don't have to, but it saves a ton of time of you guys having to go back here and being like, okay, let me figure out where the tangent is the square root of 3 over 3, do all the work for it, and then go back and finish the problem. If you already know that, okay, root 3 over 3 is a tangent, that is when my x value is the square root of 3 over 2. So I want my tangent to be positive root 3 over 3. So where on my unit circle would the ordered pair give me a positive root 3 over 3 tangent? Pi over 6 and? No, I want a positive one. Why is it 11 pi? No, I want positive. What's a negative divided by a negative? A positive, so it'd be here. All right, so my two places here would be, I'd have theta over 2 equals, what would we say? Pi over 6 and 7 pi over 6. So pi over 6. And then we have theta over 2 equals 7 pi over 6. Now the last little thing you have to do is what? Multiply both sides by 2. Perfect. So I'm going to say, okay, times 2. Times 2. So theta equals, what's 2 pi over 6? What does that reduce to?
Pi over 3.
Pi over 3, good. And then I'm going to multiply both sides by 2, multiply both sides by 2. So theta equals 14 pi over 6 is the same as 7 pi over 3. So when you have those multiple angle ones, you'll know it's a multiple angle because there'll be something with your theta, either divided by or multiplied by. So what you do is you isolate that like normal. And if you're starting off with multiplying by a number, then at the end you divide your angle. If you start off with dividing, then at the end you multiply your angle. Yes, sir.
For the one you put like square root of 3, 1. So like as soon as we get it, we can just write that down just on that quadrant.
Which part? Like here?
No, remember you told us like you don't have to memorize it. So it's only in that quadrant.
Well, okay. If you memorize this, then it's the same all the way around. So do you see here? It's a good question, Sean. Do you see here how this ordered pair starts with x is 1/2 and your y value is the square root of 3 over 2, right? So all the way around, your tangent will be the square root of 3, just depending on what quadrant it's in, is whether it's positive or negative. So like over here, 1/2, do you see how this one is x is negative 1/2 and then square root of 3 over 2?
Yeah.
So your tangent here would be negative square root of 3. Down here, where we start off with x is 1/2, it's 2 negatives, so 2 negatives would give you a positive square root of 3. Here, you go where x is 1/2, but there's a y is negative, so this would be negative square root of 3.
It's the same numbers as
All the way around, just the signs. Yep. And you're dividing, so if it's 2 positives or 2 negatives, your answer would be negative. Sorry, positive.
Zoom out one more time.
Yeah.
Why didn't you just like, I know you divide it by 3, but like squaring it, I'll just square the whole thing, right? If you were to square it to get rid of the.
You don't want to square because you don't want your tangent to be squared. You want tangent to be all by itself. Yeah. Yeah, yeah.